All right, so here we are going to go ahead and go over Theorem 11-6, which is the main, probably the most important part of this section. This is going to allow us to find the area of any regular polygon. Remembering that a regular polygon has congruent sides and congruent angles. Okay. Now that polygon is equal to, or the area of that polygon is going to be equal to half the product of what's called the apothem and something that we're a little bit more familiar with, the perimeter. So in general, we can write down the formula that the area is simply going to be equal to 1/2 times the apothem, okay, times the perimeter. Now I'm going to do a real quick proof here. Now the proof just entails showing that, well, we know this is the apothem. Okay. Obviously we can't directly relate the perimeter here, but I'm going to go ahead and call this little piece right here, I'm going to call this S. Okay. And I know that if I want to find the area of this little triangle here, well, that's just equal to 1/2 times S times A, 1/2 times the base times the height. Well, and in fact, I have a whole bunch of these triangles. So if I go ahead and draw the rest of them out, like so, excusing my slightly off drawing here, let's go ahead and assume that all of these triangles here are congruent, as they should be. And what we end up with is we end up with not only one of these, but 1, 2, 3, 4, 5, 6, 7, 8 of these. So if I want to know the area of this, I would just take the area of one triangle, 1/2 of, oh, looks like class is starting, A times S, and I would just take that and actually multiply it by 8. Well, as it turns out, if we take a look here, we can clearly see that, well, if we want to know the perimeter of this, well, it's just 1, 2, 3, 4, 5, 6, 7, 8 S's. So, well, that's just right there. That's actually just our perimeter. Okay, so we end up with a perimeter right here. Well, that ends up just being our exact formula. The area is going to just be equal to 1/2 times the apothem times the perimeter. All right, so let's take a look at some examples. So here's an initial example. The example here states that we have a radius that is equal to 5√2. And that's kind of all they give us. But since this is a square, we actually know that this right here is a right angle. And as it turns out, the radius is actually going to bisect that angle. So, and this is true of any radius. If I know that the whole angle here is 90, then this is 45. Well, in a 45, 45, 90 triangle, the generic form would say that this is x√2, and that each one of these sides here and here are just x, meaning that this side is 5 and this side is 5. Well, that's the apothem, so I now know my apothem is simply equal to 5. And the perimeter, well, the perimeter is just walking around, and if you think back to the example I gave on the last one, you would know that there are 8 of these pieces. But we could also just think of, well, that means that this length right here has to be 10. Well, if that's the case, I have 4 of those. My perimeter is 40. Well, to find the area, I would simply multiply 1/2 times the apothem, 5, times the perimeter, 40. Multiply all of that out, and you're going to wind up with an area of 100 square units. Now, moving on to the second piece here. Okay, well, now they change up our values, but I notice I'm going to keep that 45 degrees the same, because that's not going to change. And in this time instead, they just tell us that this side right here, that the apothem is in fact equal to √3. Now, I didn't put the generic forms up here, but that tells me that x is in fact equal to root 3, and that this piece right here is also equal to root 3, okay, from here to here. Well, if that's the case, well, if this piece right here is just x root 3, well, then I can replace that x with what it's equal to. I'm sorry, then, so it's going to be root 3 times root 2, which is just equal to root 6. So I now know my radius must be root 6. Okay. Now, for the next piece, we'd move along to the perimeter. Well, to find the perimeter, if I know that one of these pieces is root 3, I'm going to go ahead and take that shortcut and just realize that, let me see if you can pause it for a sec and think of how many of these root 3 pieces we have if we wanted to walk all the way around. Okay, hopefully you figured out that in this case, we actually have 8 of them. Now, if you didn't know that, or it was a different type of shape, you might want to go ahead and count them out. But in this case, we can just say that our perimeter is in fact equal to 8 of these root 3 pieces, or just 8 root 3. Okay. Now, using all that information, I know that the area is just equal to 1/2 times A times our perimeter. Well, in this case, I have 1/2. My apothem is just root 3. And my perimeter is just 8 root 3. Okay? Now we always multiply our numbers outside the house times each other. So 1/2 times 8 is just 4. And then the numbers inside the house times each other. And we get root 3 times root 3. Well, hopefully you got that those will just cancel out, and that's just 3. So we wind up with an answer of 12. Okay? All right. And